Hi all. Today our topic for the discussion is glass ionomer cement. So glass ionomer cement is any cement that contain glass powder on one hand and polyacrylic acid in other hand, that is called as glass ionomer cements. So the glass ionomer cement, the term was actually coined by Wilson and Kent. Other names of GIC include polyalkanoid cement, man-made dentine substitute, artificial dentine. And since it was introduced, when it was introduced in US, it was called as ASPA cement, that is aluminum silico polyacrylate cement. So these are the other names of GIC. Now, coming to the composition of GIC, the GIC consists of powder particles as well as liquid particle. And the powder you can memorize as the code SAC for sale. SAC is silica, A for alumina, A for again aluminum fluoride, calcium fluoride, sodium fluoride, aluminum phosphate, lanthanum, and strontium. So this is the powder composition, and where you can see silica is the composition which is more or greater quantity which is seen. Liquid consists of mainly polyacrylic acid, which accounts for 45% of the percentage. But more than that, the water is the content. Don't forget, sometimes the question might be like, which is the liquid component that is seen in a higher concentration? It is water, not polyacrylic acid. So along with polyacrylic acid, it also contains eticonic acid, malic acid, and also tartaric acid. So what is the setting reaction of GIC? For simple, what happens is like there is powder and also the liquid part is there. So the powder, we know that it consists of calcium, silica, alumina, etc. And on liquid side, it consists of the polyacrylic acid. So the first reaction is like calcium and also polyacrylic acid join together to form calcium polyacrylate. On the second portion, there is joining. This is the first reaction that take place. After 24 hours, this calcium get replaced by alumina, forming alumina polyacrylate. So this is actually a temporary phase which is not as strong as that of aluminum polyacrylate. Once aluminum polyacrylate is actually formed, it is the most strongest phase that is formed. First, what happens is like when we actually mix the powder to that of the liquid go and attacks the powder particles, and there is dissolution of all the ions, and release of ions is like the calcium, silica, alumina, etc. are actually released. Next is actually the gelation. As I said, precipitation of salt is the next step, where I explained initially calcium polyacrylate will be formed. After 24 hours, calcium get replaced by alumina, forming aluminum polyacrylate. And after that, the last stage is actually maturation often take place. Next is polyacrylic acid. So polyacrylic acid is a very important thing that is required for the cement matrix formation, and the effect of polyacrylic acid, the effect of molecular weight and the concentration of polyacrylic acid affect the utility of it as a cement. Since the molecular weight is more, it does not have much of a penetration to the tendinal tubule, thus there is less of an irritation. Next, why is eticonic acid? Eticonic acid promote the reactivity between glass and liquid, and it also prevent the gelation and less likely to have cross-linking between that. So what happens is like in early cases, the liquid had only polyacrylic acid. So what happens is like when only polyacrylic acid is seen, it continuously form a reaction with polyacrylic acid and they form a chain or gelation take place. But when eticonic acid was added, there is a polyacrylic acid, there is a eticonic acid, again polyacrylic acid. So gelation or the fast cross-linking has been inhibited, right? Tartaric acid is a particular thing that increases the working time and decreases the setting time, and also they prevent the precipitation of alumina, where it causes chelation of the aluminum ion. Now, what is the role of water in GIC? The GIC cement is actually a water-based cement. So, water play a very important role in transportation of all the ions from one part to another, and also they hydrate the cross-linked matrix and initial finally they help in the maturation of the cement. Now we have certain things called as a fluoride flux. The fluoride flux, like calcium fluoride, aluminum fluoride, and sodium fluoride, they improve the strength. So fluoride improve the strength. It decrease the melting point and improve the manipulation rate also. Now, what is the property of GIC? First is like bonding. The GIC bond to the tooth structure by chemical bonding, that is by chelation. Free carboxylic acid carboxyl group get attached to the calcium in the tooth structure. Next, comparing the strength. GIC is more stronger when compared to the other acids like zinc phosphate and zinc polycarboxylate. And you can see here the comprehensive strength is 150 MPa, the tensile strength is 6.9 MPa, and the elastic modulus is again 0.4 gigapascal. Next is thermal property. What happens is, like, we know that whenever there is change in the heat in our body, the material in our mouth expands and contract. So when the tooth expand, the restoration which we place also should expand similarly. Otherwise, what happens is, like, in between, if this is actually the tooth, we actually place the restoration. So when heat comes, this tooth actually enlarges. The restorative material should also enlarge along with that. Otherwise, there will be voids or spaces or discrepancies or fracture of the tooth taking place. The most important property of GIC is like the coefficient of thermal expansion of GIC is closer to that of the tooth. This chart is very important. See, the dentine is having a coefficient of thermal expansion of 8.3. See that of GIC, it is near to that of the enamel and the dentine. That is why it is a very apt material for sealing of the cavities. And that is why it is also called as a man-made dentine, where it is matching the properties of the enamel and the dentine. And GIC form a film thickness of 25 micron when we deal with the type 1 luting material. Pulpal response, talking about pulpal response, it is moderately acidic in nature, but it is in between the properties of zinc phosphate and zinc polycarboxylate. So pulpal response, acidic is more like zinc phosphate, followed by GIC, then only zinc polycarboxylate. Another thing is, like, initially the pH is 2 to 3. GIC have a pH of 2 to 3. After 24 hours, they get actually converted into 5.3. Now, what is fluoride release? The GIC have fluoride, and there is slight release of the fluoride, that is about 3 mm around the glass ionomer restoration. So that is because the fluoride is incorporated in the cement, it slightly releases into the oral cavity. But this is not a prolonged process. This might actually seen for 3 to 1 month, etc. So what we need to do is, like, we need to do a process called as fluoride recharge, where we'll be applying the fluoride on the surface of the restoration. Again, this is a charging method. So fluoride varnish, or we'll be brushing some fluoride containing toothpaste on the surface of the restoration, right? Now, next important property of GIC is anti-carcinogenic property. Anti-carcinogenic property is mainly because of two important things. First of all, the fluoride react with the hydroxyapatite crystals. The hydroxyapatite crystals is Ca10PO4 6 OH twice. So what happens is, like, our fluoride goes and actually replaces a hydroxyl group, forming Ca10PO4 6 F2. So this is called as fluorapatite crystals. These fluorapatite crystals that is formed by the reaction of fluoride to that of hydroxyapatite is much stronger and prevent the demineralization of the tooth. That is one reason. Another is, like, the glycolytic pathway of the microorganism, where they induce their metabolic energy. There is an enzyme called as enolase enzyme. So what fluoride does is, like, it inhibit the enolase enzyme of the glycolytic pathway. Thus, the continuous glycolysis is being prevented, right? Now coming to the recent advances in GIC. First of all, there is buffered GIC or zyanomer. The buffered GIC, to increase the pH of GIC, you can remember it as ZZ. Zinc oxide is incorporated into the GIC. This is called as buffered GIC. Another thing is, like, we know that GIC is not curable. There is nowadays light curable GIC. In the liquid, HEMA is added. To the powder, the initiators are added. So when we actually put the light, it activates the initiator. So it is called as diol cure GIC. Next is miracle mix. Miracle mix is a combination of GIC with that of the tin silver, that is of amalgam. So it is having a light blackish in color. What is cement? Cement is a combination of silver, tin and palladium, and to that the glass GIC glass material is added and made it to react. Next is resin modified GIC. Resin modified GIC, again it's like the light curable GIC where the composition of composites has been actually incorporated. So what is geomer? Geomer is actually having a combination of composite and also GIC. What is the difference? Like normally we have the GIC where the powder is mixed with the liquid. Here already pre-reacted glass ionomer technology is used. The powder and liquid is actually mixed to form a mass, and this mass has been actually incorporated to the composite resin, right? That is geomer. Another method is sandwich technique or bilayer technique. Sandwich technique means whenever we do a restoration, sometimes it might be a class 2 or other restoration, initially we give a GIC layer followed by a composite layer. This is actually called as the bilayer method or sandwich technique. It increases the GIC's retention to that of the tooth structure because it bonds to the tooth structure, and GIC releases fluoride, so it also have an anti-carcinogenic property. The tunnel restoration is a method where we will be actually preserving the marginal ridge. As I said in the last slide, last PPTs, if there is a proximal caries, instead of cutting the marginal ridge, we can form a tunnel and do the restoration. There also GIC is the restorative material commonly being used. So what are the steps in GIC placement? We know that initially we will be cleaning the tooth surface with the help of a dentine conditioner. Normally what we do is, like in a cotton, we will take the liquid of the GIC itself, that is the 10% polyacrylic acid. Sometimes others like malic acid, citric acid, hydrogen peroxide can also be actually used, that is applied for the 45 to 30, 60 seconds on the tooth structure, right? After that, once GIC sets, we will be applying a surface protection agent on the surface of GIC, that is mainly a varnish, cocoa butter, copal ether. Anything can be actually applied on the surface of the GIC. This is to prevent the attack of the water to the GIC surface, because there is a reaction taking place and there are ions which is engaged in this reaction. So when an external water comes in contact with this GIC, it will take away all the ions. So for protecting that, surface protection agents are used. So that is all about GIC. GIC, you need to know about the composition, various newer types of GIC, especially the geomer, and some of the important properties of GIC. Hope you had a nice class. Thank you.